In this unit, we will be creating an input-output circuit. The objectives of this lab are to provide an input source circuit of ones and zeros, and to provide an output display circuit. The components we'll be using for our input source circuit are a 4-position dip switch and 4 1 kilo ohm resistors. In our output display circuit, we will be using one Hex Inverter IC 74LS04, 4 330 ohm resistors, and 4 LEDs. For part 1, that's going to be our input source circuit. We're going to construct the circuit that is shown here with 1 kilo ohm resistors. The switches labeled 1, 2, 3, and 4 will come from our 4-position dip switch, and they will be connected to power via 1 kilo ohm resistors. And then the positions A, B, C, and D can then be used as inputs to other circuits as a source of ones and zeros. In part 2, then, we're going to create an output display circuit. So when we move our switches from one position to the other, we can see if they're turning the LED on or off. The LED circuit shown is connected, each LED is connected to power via 330 ohm resistor. The numbers on the inverter gates, 1, 3, 11, and 13, correspond to the input pin numbers on the 74LS04 IC. Pins 2, 4, 12, and 10 correspond to the output pin numbers. And then each of these inputs comes from inputs A, B, C, and D of our source circuit. We'll talk a little bit more about the Hex Inverter IC in a little bit. The first thing we need to do, though, is we need to set up power and ground connections on our Elvis breadboard. The breadboard on Elvis has power and ground only on one side, and that would be the side that is labeled with the DC power supplies, circled in yellow here. We need to connect the rail labeled with a minus for ground to the ground pin of the power supply row. And then similarly, the rail labeled with a plus needs to be connected to the plus 5 volt of the power supplies. Once we have power and ground set up, we're going to place our 4-position dip switch in the center of the breadboard such that it straddles the two halves. And then once our dip switch is in place, we are going to ground one side of our switches, the side of the switch labeled on. Notice that each switch, the corresponding row, one of the pins is connected to ground. Remember that each of the pins, or the holes in this row, are connected in series, so this wire could have easily been connected to any pin in the row for switch 1 and any pin in the row for switch 2, and so on. Next, we need to provide power for each switch. Since we only have power and ground on one side of our breadboard, this means that we're going to have to go from the other side of our switch over to the power rail on our breadboard. Now, since the two halves aren't connected, we're going to have to use some wires as jumpers. So notice from switch 1, we go from the row of the switch over to a row containing a jumper wire that then connects to a 1 kilo ohm resistor, which in turn is connected to power. Each of these switches is connected in a similar manner. Switch 2 is connected to another jumper row, and that half is then connected to the power half, and which is then connected to the power rail with another 1 kilo ohm resistor, and so on. Once we have our input switch, our input circuit put together properly, we are going to construct our output display circuit. For our output display circuit, we're going to need to pass each of our signals through an inverter gate. And the reason we need to do this is because Without the inverter gate, if we were to connect our switch output directly to the LED, a 1 would actually turn the LED off, and a 0 would turn it on. Well, we want what's known as positive logic, where a 1 turns the LED on, and a 0 makes it go dark. So that's why we're using this IC. You notice that it has a power pin. Pin 14 is power, and pin 7 is ground. There is a notch on the left-hand side. That lets you know if the notch is on your left that pin 1 is at the bottom left. And then from left to right, starting at the bottom left, going counterclockwise around, our input pins for each of the 6 gates on this IC are pins 1, 3, 5, 9, 11, and 13. Similarly, our output pins are going to be pins 2, 4, 6, 8, 10, and 12. There are 6 gates on this IC, but we are only going to use 4 of them. The choice of which 4 is arbitrary. I picked the leftmost 4 just because that puts them closer to our dip switches, so we don't need quite as long of wires. But you may choose any of the 4 of the 6 that you would like. Okay, we're going to place our Hex Inverter IC, again in the middle so it straddles both halves. Notice that the notch is to the left, and you should also be able to read the text on the IC from left to right if it is positioned correctly. We then provide power and ground to our Hex Inverter IC. Pin 14 is provides power. So pin 14 is connected via a jumper wire over to the power rail. And then pin 7 is connected to the ground rail. It is already on the same side as the ground rail, so we don't need a jumper to connect that one. Again, don't forget that the choice of which of the 4 inverters to be used is arbitrary. In my circuit, I connected, again, the leftmost 4. And that's our next step. We're going to connect each switch from our input circuit to the inverter inputs for our output circuit. We connect switch 1 to the input of an inverter, switch 2, switch 3, and then of course switch 4. Then we're going to connect the output of the inverter for the first switch to the negative leg of the LED. And the negative leg is the shorter side. Remember, long side to power, short side to ground. Once that is done, the long side of that LED, the positive side, is going to be connected, possibly via jumper wire, to a 330 ohm resistor, which is then connected to power. Then we'll connect the output of the other 3 inverters to their corresponding LEDs in a similar manner. Once this is complete, we can test our circuit, and hopefully everything works accordingly. Let's see how we did. So far so good. 2, 3, and 4. All of our LEDs came on. And flipping the switches again then turns them off. Please verify that your circuit works accordingly. If not, please let me know if you have questions, and then proceed to the lab report.